In this particular exercise, we are going to graph a logarithmic equation that has some transformations in it. We are going to graph f of x is equal to log base 2 of x minus 4 plus 1. Recall that since the x minus 4 is in the argument, our graph will shift to the right 4 places. The plus 1 on the outside means our graph will shift upwards 1 place. Now, originally, a logarithmic graph that has no transformations in it at all would have a vertical asymptote at x equals 0. But now, since we are going to the right 4 places, that vertical asymptote will shift over to x equals 4. Now, originally, a logarithmic graph with no transformations would have an x-intercept at 1, 0. Well, that point now has moved 1, 2, 3, 4 places to the right and up 1. So that point now is happening at 5, 1. In order to go ahead and find the proper x-intercept now, we need to solve this further. I will have that 0 is equal to log base 2 of x minus 4 plus 1. Subtracting the 1 to the other side, we now have that a negative 1 is equal to log base 2 of x minus 4. Changing my logarithm now into an exponential in order to solve for my x variable of 2 to the negative first power equals x minus 4. Well, 2 to the negative first power is the same as 1/2. So, continuing downwards and adding the 4 on over to the other side, x would be equal to 4.5. So that means I would have an x-intercept occurring at 4.5, 0. Thus, we can go ahead and sketch our logarithmic graph accordingly. In order to graph an exponential or a logarithmic equation, you can go ahead and use the same transformations you use for your toolbox functions.